students, welcome back. I am Rinkesh sir, and today we'll start with a new chapter, that is chapter number 8, Binomial Theorem. Okay, so before starting exercise 8.1, let's study some basics. Okay, now if we see a plus b whole raised to 0, then this will be equal to 1. A plus b whole raised to 1, then that will be equal to a plus b. A plus b whole square, that will be equal to a square plus 2ab plus b square. A plus b whole cube, this will be a cube plus 3a square b plus 3ab square plus b cube. Generally, we are adding a cube plus b cube plus 3a square b plus 3ab square. But I just rearranged it. And if I will take a plus b whole raised to 4, then this will be equal to a plus b whole cube into a plus b. So a instead of a plus b whole cube, I will put a cube plus 3a square will be plus 3ab square plus b cube into a plus b. When I will solve it, I will get a raised to 4 plus 4a cube b plus 6a square b square plus 4ab cube plus b raised to 4. Okay, when I will solve this, I will get that. Okay, so now say just following this pattern, if I check about the coefficient with respect to this power, okay, so I am writing here index and coefficient. When the index is 0, what is the coefficient? 1, right? We are not having neither a nor b, so I will write down only 1. When the index is 1, see, it's 1a plus 1b. So I will write down 1a plus 1b. Okay. When I will take the power as 2, index as 2, it will be 1a square 2ab plus b square. So I can write in this way. 1a square plus 2ab means 2 plus b square. So this way. Okay, the third power is 1. When I will take index as 3, it's 1a cube plus 3a square plus 3ab plus b. Okay, so I will write down this as 1 into a cube plus 3 into a square b plus 3 into ab square plus 1b cube. Okay, when I will take power as 4, let me rearrange this. When I will take power as 4, you can see 1a raised to 4, 4a cube b, 6a square b, 4ab cube and 1b raised to 4. So this will be equal to 1 into a raised to 4 plus 4 a cube b plus 6 a square b plus 4 a cube b plus 1 b raised to 4. Okay, so now these are the arrangement of the coefficients. So now we can see that it forms a pattern. Using that pattern, we can also write down more rows. Okay, we can find out the coefficients without solving it. Now let's check the pattern. This is the pattern. Now see here, at every base of this triangle at top it's 1. Right? In this case, and here it's 2. Now if I take the vertices, this 1 plus 1, I will get 2. 1 plus 2, I will get 3. 1 plus 3, I will get 4. 3 plus 3, I will get 6. 3 plus 1, I will get 4. 2 plus 1, I will get 3. Right? So this is the pattern that is followed here. Okay, so this is called Pascal's triangle. Okay, after the name of him, Pascal's triangle. So Pascal just found out this pattern, so it's named as Pascal's triangle. French mathematician Blaise Pascal, it's named after him, Pascal's triangle. Using this, if I want to form a fifth row, okay, means if the power is 5, okay, I can use these triangles. So here it will be 1, 1 plus 4, 5, 4 plus 6, 10, 6 plus 4, 10, 4 plus 1, 5 and 1. Okay, so we can easily find out the next rows. Clear? So this is about Pascal's triangle. Now, this we can write it in other way. Now see, when the power is 0, index is 0, this one I will write it down as 0C0. Right? That is equal to 1. When the power is 1, 1C0, 1C1. Okay, when the power is 2, 2C0 equal to 1. 2C1 equal to 2. 2C2 equal to 1. When the power is 3, 3C0, 1. 3C1, 3. 3C2, 3. 3C3, 1. Okay, we are using this combination like NCR. We used it in previous chapters, chapter number 7. N factorial upon R factorial into N minus R factorial. Okay, again when the power is 4, I will start with 4. 4C0, 4C1, 4C2, 4C3 and 4C4, that is equal to, when you solve it, you will get these numbers only. Okay, so we will use these concepts in the binomial theorem. Okay, we will combine this Pascal's triangle and this. See here the coefficient, sorry, the variables. If it is a plus b, see the power of a, n is 4. So 4, 3, 2, 1 and nothing means 0. And the power of b, nothing is there in first, so 0, b raised to 1, b square, b raised to 3, b raised to 4. Okay, so from that we can derive a formula, or we will derive a formula. We will use the binomial theorem like p of n, if it is a plus b raised to n, then this will be equal to, now see what about the coefficients. First we are using nc0, then nc1, nc2, nc3 up to last NCN, right? See here 4C0, 4C1, 4C2, 4C3, 4C4, right? These are these 4C0, 4C1, 4C2, 4C3, 4C4. So I have taken this way NC0, NC1, NC2, NC3, NC4. Okay, now see the power a raised to n, a raised to then n minus 1, a raised to n minus 2, a raised to n minus 3 and up to last a raised to 0. And here power starting with b raised to 0, b raised to 1, b raised to 2, b raised to 3 and finally b raised to n. We will add. Okay, so this will be our formula for binomial theorem. Okay, see this is nc0, so a raised to power is n and b raised to power is 0. nc1, so the power will be n minus 1 of a and for b it's 1. nc2, so power of a n minus 2 and b 2. Clear? So this will be the formula for p of n. Now if I take p of n equal to a minus b raised to n. Now it is minus sign. See, now for every case I will take instead of b minus b. So minus b raised to 0 it will be 1. But minus b raised to 1, it will be minus b. So instead of plus, there will be minus. Minus b square, it will be plus b square, so it will be plus. So we will use alternate negative sign like nc0, a raised to n, b raised to 0. So before this, it's plus. So now minus nc1, a raised to n minus 1, b. Now plus nc2, a raised to n minus 2, b square. Next minus nc3, a raised to n minus 3, b raised to 3, then plus dot dot dot. And finally ncn, a raised to 0, b raised to n. Okay, now it depends. If n is even, here there will be negative sign. Sorry, positive sign. If n is odd, before this there will be negative sign. See, remember, when it is 1, minus sign, 2, plus sign, 3, minus sign. Okay, and so on. So if n is even, plus, n is odd, minus sign. Clear? So we will use this formula for solving exercise 8.1. Okay? So just note it down. Now let's start with exercise 8.1. Expand each of the following in exercise 1 to 5. Okay, so 1 to 5 we will be using the same formula. So I will solve 3 of them, and the rest of the 2 you have to solve it by yourself. Okay, so first I will solve question number second. It's 2 by x minus x by 2 whole raised to 5. Here a is equal to 2 by x and b is equal to x by 2 raised to 5. So what was our formula first? And now see, it is negative sign in between. So alternate we will put minus sign. So first is nc0. A raised to n means 2 by x whole raised to 5. B raised to n, b raised to 0 means x by 2 whole raised to 0 minus nc1, a raised to n minus 1. Sorry, what is n here? 5. So instead of n, I will put 5. Same way here. 5c1, a raised to n minus 1. So here what is a? 2 by x. And n minus 1 is 5 minus 1, 4. And b, x by 2 power is 1. Now see, for a you need to reduce the power by 1, and for b you need to increase the power by 1. Okay, so now after minus, plus 5c2, 2 by x, reduce it by 1, so 3, x by 2, reduce it by 1, so 2, plus 5c3, 2 by x, reduce it by 1, so 2, and x by 2, so 3, plus 5c4, 2 by x whole raised to 1, x by 2 whole raised to 4, plus 5c5, 2 by x whole raised to 0, x by 2 whole raised to 4. Okay, so this will be equal to 5c0. We are in shortcut, so we'll use a shortcut. nc0 equal to 1, nc1 equal to n, and ncn minus ncr equal to ncn minus r. Clear? So first 5c0, 1, 2 by x, so 2 raised to 5, that is 32 upon x raised to 5. Okay, and raised to 0, x by 2 raised to 0, that is equal to 1, minus 5c1, that is nc1n, so it will be 5. 2 raised to 4, that is 16, and x raised to 4, x raised to 4. into x raised to 1, 1, 2 raised to 1, 2 plus 5c2, let's solve it separately. 5 factorial upon 2 factorial, 5 minus 2, 3 factorial. This will be 5 into 4 into 3 factorial upon 2 factorial 2 and 3 factorial this. So 2 ones are, just a minute, 2 ones are, 2 twos are. So 5 twos are 10. So this will be equal to 5c2 10. 2 cube 8 upon x cube into x square into 2 square, that is 4, plus 5c3, that will be 5c, 5 minus 3 2, we'll use this formula. Okay, 5 minus 3, that is 2, so it will be value of 5c2 only, so that is 10. Okay, we made some mistake here. Here will be minus, here also will be minus. It's minus 10, 2 raised to 2 4 upon x square, x cube 2 cube, that is 8, plus 5c4, that is 5 minus 4 1, so 5c1, that is 5, 2 by x, x raised to 4 and 2 raised to 4 16, minus 5c5, that is, again I am writing here shortcut ncn, that will be also equal to 1. This will be 1, 2 by x raised to 0, that is 1, so x raised to 4 upon 32. This will be equal to 32 by x raised to 5 minus 2 ones are 2 eights are, and x, and here will be cube, minus 5 by x cube plus 4 ones are, sorry, yes, 4 ones are 4 twos are, so plus 20, and x square here will be cancelled by x minus, okay, 4 ones are 4 twos are, and 2 ones are 2 fives are, and x square here will get cancelled, so minus 5x plus 2 ones are 2 eights are, so it's 5 by 8, and x here will be cube, x cube minus x raised to 4 by 32. Clear? So this is our answer. Okay, so just note it down. So we made one mistake. 5 eights are here will be 40, not 45. It will be 40. Okay, now note it down. Now let's see one more. Now I'll solve question number 3. Question number 3 is 2x minus 3 whole raised to 6. Same way, n is 3, a 2x, b 3, and a negative sign in between. So alternate minus. So first 6c 0, a 2x raised to 6, b 3 raised to 0, minus 6c1, 2x raised to 6 minus 1, 5, 3 raised to 1, plus 6c2, 2x raised to 6 minus 2, 4, 3 square, plus 6c3, 2x raised to 3, 3 cube, sorry, there will be minus sign, plus 6c4, 2x square, 3 raised to 4, minus 6c5, 2x raised to 1, 3 raised to 5, plus 6c6, 2x raised to 0, 3 raised to 6. Okay, so now 6c0, that is 1, 2x raised to 6, so 2 raised to 6, that is equal to 64, x raised to 6 and 3 raised to 0, 1 minus 61 that is 6, 2 raised to 5 that is 32, x raised to 5 into 3 plus 6c2, so 6 factorial, 2 factorial, 6 minus 2, 4 factorial. 6 into 5 into 4 upon 2 into 4. 2 ones are 2 threes are 5 threes are 15. Okay, so 6c2 that is 15. So I will solve 15. 2 raised to 4 that is 16. X raised to 4 and 3 raised 3 square that is 9. Okay, now 6c3 similarly we will solve it. We will get 20 into 2 cube that is 8 x cube into 3 cube 27. 6c4 that is 6c6 minus 4 62 that will be equal to again 15 into 2 square 4 x square and 3 raised to 4 that is 81 minus 65 that is equal to 61, so 6 into 2x into 3 raised to 5 that is 243 plus 66 1 into 2, sorry, 2 raised to 0 x raised to 0 to be 1 only, so no need to write down, into 3 raised to 6 means 243 into 6 that will be 729. So this will be 64 x raised to 6 minus 6 into 32 into 3 that will be 576 x raised to 5 plus 15 into 16 into 9 that is 2160 x raised to 4 minus 20 into 8 into 27 that will be 4860 x cube. You can calculate directly by calculator plus 15 into 4 into 81 that will be equal to, sorry, there is a mistake. Sorry, 20 into 8 into 27, 20 into 8, 1. This will be 4320 plus 15 into 4 into 81. This will be equal to 4860 x square minus 6 into 2, 12, 12 into 2, 43, that will be equal to 2916 x plus 729. Okay, so this was about question number 3rd. Just note it down. Now let's see one more question, that is question number 4. Question 4 is x by 3 plus 1 by x whole raised to 5. So a is x by 3, b is 1 by x, and n is equal to 5. 5c0 x by 3 raised to 5. Now no need to add 1 by x, it will be raised to 0, so 1. And there's plus sign in between. So everywhere plus. Plus 5c1 x by 3 raised to 4 and 1 by x raised to 1 plus 5c2 x by 3 raised to 3 1 by x raised to 2 plus 5c3, sorry, yes, x by 3 raised to 2 1 by x raised to 3 plus 5c4 x by 3 raised to 1 1 by x raised to 4 plus 5c5 x by 3 raised to 0. So no need to write it down now. Directly 1 by x raised to 5. Okay. Now, 5C0, we know that's 1 x raised to 5 upon 3 raised to 5, that is 243. We just calculated the last sum. Plus 5C1, that is 5. X raised to 4, 3 raised to 4, that is 81 into 1 by x. Plus 5C2, that will be equal to 10 into x cube upon 3 cube 9 into 1 upon x square plus 5C3, that will be equal to 5C2, so 10 into x square by 9 into 1 by x cube plus 5C4, that will be equal to 5C1, so 5 into x by 3 into 1 by x raised to 4 plus 5C5, that is equal to 5C0, so 1 into 1 by x raised to 5. This will be equal to x raised to 5 upon 243 plus, here it will be, x will get cancelled, so cube 5x cube upon 81. Here x square will get cancelled, so only x will be remaining. So plus 10x by 9 plus, okay, here x will be remaining in denominator, 10 by 9x plus, here in denominator it will be x cube, so 5 by 3x cube plus 1 upon x raised to 5. Here, so this was about question number 4. Just note it down. Okay, so we have solved question 2, 3 and 4. So based on that method, you have to solve question 1 and 5 by yourself. Okay, so that's it for today. Thank you.